All right, let's review yesterday. Let's go through the 5 function families that we talked about. The first one we talked about was linear function family. Okay, so write this down. So what are some of the characteristics of a linear function family? Okay, one, pretty obvious. The graph is a straight line. All lines that we deal with will be straight. So it's kind of redundant to say straight line, but we seem to always say that. All right, what else do we know about it? What about the equation? What do we say about the equation? Kiana? Yeah, we said the x and y will be to the first power. Now remember, that means a couple of different things. We could have the most common we like to see it is y equals, say, 3x plus 2. Notice your x and y are to the first power. We could have 2x plus 3y equals 6. Those are both to the first power. Or we could have y equals 3, and we can have x equals 3, but x equals 3 really isn't a function, is it? It's a linear equation, but not a function. Okay, so that one's kind of special. All right. Any questions on linear equations? Linear function family. Okay. The next one we talked about was linear absolute value. Okay, and by the way, I wanted to say number 2 up here was from the linear absolute value function family, wasn't it? This guy was linear. Okay, and number 6 is from the linear absolute value function family. It has 2 lines. It's made up of 2 lines that create a V-shaped graph, right? So linear absolute value, the first thing is, I just said it, the graph is V-shaped, right? And then we said what? The equation will have the absolute value bars, right? The equation will have the absolute value bars. So we're not very clever in our naming of these function families, are we? Linear absolute value function family will look like this. Y equals the absolute value of x plus 3. Or we could have y equals the absolute value of x plus 3 like that. Or if we want to get really crazy, we could have y equals the absolute value of x minus 2 plus 3. And that thing will do a bunch of different changes, right? So in all of these equations, you see the absolute value signs, or bars if you want. So that's how we know it's an absolute value this way. And when we see the graph, it will be V-shaped, much like number 6 here, right? So that's linear absolute value. Right? Okay. Then the third one we talked about was, you guys remember? No, not yet. Actually, I think we talked about quadratic next. Quadratic function family. And we said the quadratic graph will be what? U-shaped. I'm not a big fan of U-shaped because it's more of a fat V. It's called a parabola, right? Okay, it's kind of a fat V. And we said the equation will what? The equation is always what? Anybody? Always to the second power. The equation is always to the second power. Like y equals x squared. That's the most basic quadratic equation. Could be y equals 3x squared plus 2x minus 1. That's a quadratic equation. The key here is they're both to the second power, right? So quadratic equations will always be to the second power. And if we go back up here, we look at number 4. That's a quadratic equation. You can see it's kind of U-shaped, kind of V-shaped. Hopefully you can see why I like fat V more than I do U-shaped. Okay, it's kind of a V. It's very similar to the absolute value function family, except it's more rounded. Okay, next we talked about exponential. And we said one really important, first of all, let's talk about the graph. The graph, we say, is a smooth curve. And that is just like, what number in our worksheet? Number 1? Very good. Yep, just like number 1. It's a smooth curve. Starts off slow and picks up speed really fast. I showed you yesterday how you could make millions of dollars in 30 days, right? Seems pretty easy. Did anybody convince their parents to do that for them? No? All right. So it's a smooth curve. All right. And the equation, we had a sentence. What was the sentence? X is the exponent of an exponential equation. You'll hear that sentence a lot in the next, well, couple of days. X is the exponent of an exponential equation. Okay, X is the exponent of an exponential equation. So, y equals 3x plus 2. Y equals 2, whoops, nope, not there. 2x, it's the exponent minus 5. X is the exponent in an exponential equation. All right, and finally the last one real quick is piecewise, which we won't hardly even talk about. Actually, one word, piecewise function family. Family, boy, I'm in trouble writing. And a piecewise graph, I'll say graph will change directions. That's not really graph. I'm going to just draw it. A piecewise graph will sometimes go like this. It'll change directions, and the equation will usually be something like this. You won't even use this until Math 3. If you go into Math 3 is when you'll really get into piecewise. Advanced math, calculus. So unless you're really going far in math, you probably won't see piecewise. That's why we really don't spend any time on it other than to help you identify it. Okay. So with all those notes from yesterday, we just kind of repeated that. Let's quickly go through. Did everybody get those okay? Yes? Okay. So let's just name them real quick. What is this guy? Exponential. We said this guy was linear. What's this guy? Piecewise. Piece. How about this guy? Quadratic. Linear. And linear absolute value. So this guy is exponential, quadratic, linear, exponential, x is the exponent, linear, quadratic, x squared, linear absolute value, got the absolute value bars, and piecewise. Okay, linear, piecewise, or just piecewise is fine. Okay, we're not going to go through these. I'll just go through them quickly. Instead of matching up this way, linear absolute value, linear, quadratic, linear. That one we don't even need to worry about. That's a dummy in there to trick you. Quadratic, linear, exponential, x is the exponent, piecewise, linear, piecewise. Okay? All right, so let's turn the page over. All right, so there's some other characteristics we want you to learn about all graphs, okay? So some of the other characteristics a graph can have. It can be, first of all, and we've talked about some of these already, a graph can be discrete. Do you remember what discrete graphs look like? What are they? Dotted. Dotted, that's right. A discrete graph will be dotted. Okay? And then the next one would be, if the opposite of discrete is continuous. And that would be just a solid line, right? Okay, so we have discrete and continuous. We have obviously a straight line. We've already talked about that. So the other thing is a graph can be increasing. And when we talk about increasing, we are always talking from left to right. So when a graph is increasing, we're talking from left to right. So the other way of saying it is, as x gets bigger, y gets bigger. This would be an increasing continuous graph. Okay? As x gets bigger, y is getting bigger. As we move across from left to right, we're going up. And decreasing would mean just the opposite of that. As x is getting larger, y is getting smaller, isn't it? So that's an example of a decreasing graph. Okay, and sometimes graphs can do both. All right? Think about a linear absolute value graph. Let's take the most basic one we've worked with. Can you guys still see that? Okay. So this is a linear absolute value graph, correct? Now don't get hung up on the arrows. This one is decreasing in quadrant 2, but increasing in quadrant 1, isn't it? So sometimes graphs can do both. Think about a parabola for a quadratic equation. In this case, we have an upside down parabola, and it's actually increasing in quadrant 3, but decreasing in quadrant 4, isn't it? Okay, so graphs can do both. Which leads me to the next one, which is what we say an absolute maximum. And if we look at these lines over here, we don't have an absolute maximum. They just keep getting higher and higher and higher. But if you look at this parabola right here, it has an absolute maximum, the highest point. It goes up, it increases, it gets to that highest point, and then decreases, doesn't it? So this graph right here has an absolute maximum, the highest point, the peak of the mountain. Okay? And, excuse me?
Don't graphs that like do horsepower and torque have absolute maximums? And they slowly curve down after that?
Yeah, they probably would, yeah. And then we have an absolute minimum that goes with that, which would be this graph right here. Okay, it has an absolute minimum. It's decreasing, it gets to the smallest point, and then it starts increasing. So that would be the absolute minimum, the lowest point in the valley. Okay? And we might as well cover, there might be more that I add later, but there's two others that I want to talk about. One is the domain. We've talked about that before. What's the domain? All of the x values is the domain. And what goes with that is the range. What do you think the range is?
All the y values.
That's right. Okay, and I believe I forgot one that I also have talked about previously. Is another characteristic a graph can have is, I said they can be straight lines, right? It can be linear, or they could have a smooth curve. And we usually reserve that one for a exponential equation. Is usually a smooth curve. It might start slow and increase this way, or it could decrease very quickly and then kind of slow down. Okay, so that's an example of a smooth curve. All right? So let's do worksheet 2 together. And we're going to talk about some of these characteristics in our description. All right. So, worksheet 2, choose the appropriate function family or families to complete each sentence based on the given characteristics. Okay, and our linear function family, linear absolute value function family, quadratic and exponential. Notice piecewise isn't in there because, again, I said we won't talk about it a lot. All right, so the graph of this function family is a straight line. The function family is linear. That's right, linear. Now remember, linear absolute values are made up of lines too, but it's made up of two lines. And this says a straight line, I think, meaning singular, so we'll just go with linear function. Linear function. Okay, number 2. The graph of the function family has an increasing interval and a decreasing interval. The function family is linear absolute value. Okay. has an increasing function, has an increasing interval and a decreasing interval. So that would be an absolute value function that looks like this. Increasing and then decreasing. So a graph that has an increasing and decreasing interval might be, let's see, it might be y equals negative the absolute value of x, probably plus, let's just say 2. All right, so is that the only function family that has an increasing interval and then a decreasing interval? What's the other one? No. Quadratic. Okay, because remember, quadratic is that fat V, right? And it could look like this. I'm not great at drawing parabolas, but it could look like, say, I'll just draw it like this. Here's our increasing interval, and here's our decreasing interval. And this graph might be y equals, just like the absolute value has the negative out front that makes it go upside down, same with the, if it has a negative in front of the x squared, it makes it open down. Okay, so that negative in the absolute value makes it open down, and the negative in front of the x squared makes it open down. Okay? So we have two that have an increasing and decreasing interval. All right, the function family that has an absolute minimum, the function family is? No. It's these two right here. Remember, if they're V-shaped, they have to have an absolute maximum. In this case, these two have absolute maximums, but if they opened up the other way, they would have absolute minimums. There's a linear absolute value that has an absolute minimum, and then a quadratic that has an absolute minimum would look much the same. It's just more rounded. So again, it's going to be, I'm going to put them down here, linear absolute value. I didn't leave myself much room. Value, can you guys see that?
Yeah.
Linear absolute value and quadratic. So if it has an increasing interval and a decreasing interval, it will have an absolute maximum. If it has a decreasing interval and then an increasing interval, it will have an absolute minimum. Okay. The graph of the function family in, let's see, read that here. The graph of the function family in is, I think that's supposed to be is, decreasing over the entire domain. The function family is, what function family would be decreasing over the entire domain? We've got two. It could be a linear, right? Couldn't a linear function family be decreasing over the entire domain? Could have a line that goes like this, correct? A line could be decreasing over the entire domain, but so could an exponential. An exponential will decrease very quickly, and then it slows down, but it continues to decrease and decrease and get smaller and smaller and smaller. Even though it's getting smaller by a very tiny fraction, it still continues to get smaller. And we'll talk more about those tomorrow. So in this one, it is linear and exponential. So linear, I think you can understand why it decreases over the entire interval, right? Just draw one very quickly. So if we have something with a negative slope, it's negative over the entire graph, right? It's always getting, as x gets larger, y is getting smaller. Okay? Now an example of a exponential equation that continues to get smaller would be this graph right here. Okay? So when x equals 0, y equals 1. When we plug in 0 for x, anything to the 0 power equals 1, correct? Anything to the 0 power equals 1. We talked about that earlier in the year. That's one of those things you're supposed to know from junior high. Anything to the 0 power equals 1. So we'll call this 1 right here. So at 0, this equals, oh, I'm sorry, I wanted this to be 1/2. 1/2, sorry. 1/2 to the 0 power. Okay? 1/2. Anything to the 0 power equals 1. Okay? But y equals 1/2 to the first power equals 1/2. Okay? So at 1, it equals 1/2 of that. And then when you go to y equals 1/2 to the second power, you actually get 1/4, which would be right here. And then if you take y equals 1/2 to the third, you actually get 1/8. And so as you go across, as x is getting bigger, remember x is the exponent, as your exponent continues to get bigger, y continues to be halved every time. So we were at 1, 1/2, 1/4, 1/8, 1/16, 1/32, 1/64. Remember that those numbers we did, don't they sound familiar from yesterday?
But they're not quite 0 yet.
They're never 0. They will never reach 0. It'll be 1/64, 1 over 128, 1 over 256, 1 over 512, 1 over 1024. That's a very small number, isn't it? 1 over 1024. That's a tiny little number. So, oh, next we must get to 0. Nope. It's going to be 1 over 2048. Just keeps getting smaller and smaller and smaller, but it will never reach 0. So our graph, very quickly, you won't even be able to tell there's any space between it and 0. But there'll be this tiny, tiny little space. It will never quite get to 0. Eventually, it might be 1 over 10 million. Okay, we couldn't see that. Not even probably with a microscope. But there's still a tiny little space there, isn't there? Okay, so this continues to decrease over the entire interval. It's an exponential equation. Okay, the graph of the function family forms a V shape. What's that? Absolute value. Linear absolute value. Usually, I have to admit, we usually call the quadratics U-shaped. Okay? I'm just not a big fan of that name. All right, number 6. The graph of the function family has an increasing interval and a decreasing interval and forms a U-shape. What's that function family? Quadratic. Okay, number 7. The graph of the function family does not have an absolute maximum or absolute minimum and is a smooth curve. The function family is a exponential. That's right. So remember, linear function family and exponential function family do not have an absolute maximum or minimum, but they are increasing or decreasing over the entire interval. But this one says curve. Well, a line isn't curved, so exponential. Okay, number 8. The graph of the function family is made up of straight lines and does not have an absolute maximum or minimum. What's that? It's made up of straight lines but doesn't have a maximum or a minimum.
Linear.
Linear. There's only two that are made up of straight lines, linear and linear absolute value. They both have linear in the name, but linear absolute value will have either a maximum or a minimum, right? Okay, number 9. The graph of the function family is made up of straight lines and does not have... Oops, I'm sorry, I already did that one. Wait a minute, are they the same? The function family has Oh, is made up of straight lines. Oh, you know what, guys? I did these out of order. Sorry. Let's read number 8 again. The graph of the function family has an absolute maximum or absolute minimum and is made up of straight lines. What's that one? You don't even have to erase. Linear absolute value. And then number 9, the graph of the function family is made up of straight lines and does not have a maximum or minimum. That one's just linear, isn't it? Sorry about that.
It's okay.
And number 10, the graph of the function family decreases over the entire domain and is a smooth curve. The function family is a exponential. Exponential. Did you get them all down? All right.